We're going to begin the lesson on functions. We're going to talk about the terms that we need to learn here: relation, domain, and range. A relation are a set of ordered pairs. And a set of ordered pairs has coordinates x and y. So any set of ordered pairs is a relation. The domain is the values for x, so the set of all x values. These are the input values in a function. And the range is the set of all y values. And we call these the output. There's different ways we can show a relation, and we can use the equation y equals 2x minus 1 to get some values for our function or our relation. We can set our ordered pairs in a table format, x and y chart. So if you substitute the value for 0 into this equation, y equals 2x minus 1. If you substitute 0 in, 2 times 0 is 0, minus 1 is negative 1. Substitute 1 in for x. 2 times 1 minus 1 is 1. You can substitute 2. 2 times 2 is 4, minus 1 is 3, and so on. This is a table format. We could also write this as an ordered pair format. We can use brackets and list all the ordered pairs. 0, negative 1, 1, 1, 2, 3, and 3, 5. And it can go on for infinite numbers of points. We could also map. In mapping, we put all the x values in the first oval and the y values in the second oval. Just list them, 0, 1, 2, 3. And then 0 gets mapped onto negative 1, 1, 3, and 5. These all get mapped to one specific number. This is the domain, and the y's represent your range. So you have the domain values and the range values. We could also graph these. And we can just set up a quick little graph here. Zero, negative 1, 1, 1, 2, 3, and 3, 5. A function is a relation in which each element of the domain has only one element of the range associated with in its range. Each x value is paired with only one y. That's what that means. Each x value is paired with only one y value. That is important to remember. So if we talk about a function, we can think of it in terms of a machine. Here's our little machine. It has a function. Think of it maybe as a computer. We input something into our computer, and the computer is going to output something. Well, what we input is our x value, and what we output is our f of x value. F of x is another way of saying y. It's just another way of saying, it's called function notation for the y. So x is our input. This is our independent variable. And our dependent variable is f of x. Known as y. So function notation is basically f of x, and that is just another name for y. And we will be using f of x notation from now on in Algebra 2. So we read this as f of x. That's how you say it, f of x. Now, functions, you can tell if a relation is a function or not in a graph by using the vertical line test. So let's draw a couple sample graphs here. If we have a little graph that looks like this, a vertical line test is when you take a vertical line and go through it at any point, and your line will only hit the function in one place at a time. So this is a function because it passes the vertical line test. Draw another quick graph. Here's our function, or here's our relation, I should say. Is it a function? Well, we use the vertical line test to check. Since each vertical line only hit the function in one place, it is a function. So those two are examples of functions. Now I'll show you some examples of not functions. So if I draw a graph that looks something like this, and use my vertical line test, notice my vertical line hits my function in two places. That means it fails the vertical line test. So it's not a function. I can give one more example here. If you had that graph, this would also fail the vertical line test because it hits the function in two places. So that is not a function either. Notice what we said was a function. Each x value is paired with only one y value. These x values only have one y value associated with them. But if you go here, this specific x value right here has two y's that go with it. That's why it is not a function.